Um, I was here on a few talks, and somehow I surprised that no one used this as an opportunity to joke about that. Welcome to my Netflix special. There will be people from Netflix recording the show, so make some noise in the room. So I'm using this as an opportunity to do this. Just to check, this is the talk about Kubernetes and from ground up, like all the things that you need to know to send the data into your applications when they deploy it into Kubernetes. Essentially, what I will break down today for you is the way what is happening every time when you either try to hit API or open this with your tool that you use for testing your APIs, or using your browser, like how these routes, how all the traffic will go and reach particular pod that have application deployed, all the load balancers and all the things that happens with your traffic. Also, along the way, we'll try to do some interesting things. For example, we will see how we can do something with this traffic without going and changing application. For example, how we can serve some of the D2 responsibilities, like providing termination, SSL termination, or rate limiting for your applications. My name is Viktor Gamov. I work as a principal developer advocate at Kong. And at Kong, we build different tools to help people to do everything what they need to do with cloud-native connectivity. Kong Gateway is probably one of the biggest and most popular open source gateways, sort of 45,000 stars on a GitHub, so it is kind of a big deal. And today I'm going to talk about another open source project that we developed at Kong. It's called Kong Ingress Controller that will help to translate Kubernetes native configurations into the form that the Kong gateway will digest. But before we jump into all these examples, let me talk a little bit about history and why you need to know this and why you need to care about this, first of all. So let's gonna start with the brief explanation how the networking Kubernetes works. We go into this ingress object that is the standard way to expose your service to outside world. We're going to look how it is good thing and what kind of bad things are coming into, what are shortcomings of this ingress object. We will talk about what is happening in the community and how the community try to address some of the shortcomings of the ingress object. So we're going to see what is happening after ingress. So essentially, past, present, and the future of this technology. Let's start with the Kubernetes native apps. So you deploy your app. Usually it is containerized. Most likely it's containerized. Some of the tools make these things easier. So if you're not preparing your containers, there are some tools that can do this for you. And in Kubernetes, you deploy everything in pods. And if you deploy your application, say you have application that has orders, you can have multiple pods. Those pods can include one or many containers, and each of those can or cannot expose some of the ports, so those things can be exposed outside world. Specifically, if I would like my application to be exposed outside world, I need to put something in front of it, so the load or request will be balanced across multiple different pods, because Kubernetes allow me to scale my application easily. I can specify a number of replicas. In this particular case, I have only 3 replicas, but I can scale this up, scale this down, and this should not affect the way how your users accept interact with your application. And in the world of Kubernetes, it's done through the multiple ways. So let me show you one quick thing that you can do right now. I will be using some of the APIs that I developed, and those APIs are pretty cool. One is the API that we're going to explore right now. It's the Back to Future API. And one of the services that this particular API exposes, it is called type of cluster IP. What does it mean? It's routed inside Kubernetes cluster. So within Kubernetes cluster, any application can access to this one. But what I need to do in order to access this application to outside world, easiest possible way, if you try to Google or ask your ChatGPT, they will say, hey, use port forwarding. So we're going to use port forwarding. for this. And for this service, we're going to do port forwarding. So what will happen here, it creates a tunnel between this Kubernetes cluster and your local machine. So you're on your local machine, if you go and hit this local host, you will get the response from back to future service. This is not very scalable. You cannot just like give everyone access to your Kubernetes cluster for your users. You want to do something that allows you to kind of give external access to your system, to your users. So in this case, the type of the service can be changed to load balancer. So in this particular case, if I will go and say type load balancer, with a little bit of luck and a little bit of cloud magic, and this particular cluster is running in Google Cloud, and Google Cloud provides external globally routed IP address that would be associated with particular load balancer. So I changed the type of my service. So now I don't need to have my port forwarding. So let me delete this port forwarding from now and get back to our service. In a few seconds, I will see external IP address that everyone in this room can try to hit with your favorite tool, and you should be able to get access to this API. So if I will get this one and get back to my tool, and I hit this, of course, I didn't specify the port. I need to specify port. And I get the response. So that's the easiest way how you can do external access to your application. Just annotate your service inside the Kubernetes. It also will be load balanced, but you don't know what kind of underlying technology. You need to rely on technology of your Kubernetes cluster vendor. So that's how load balancer thingy works. When you start growing your applications, you're running multiple applications Kubernetes, because why wouldn't you? Because Kubernetes gives you ability to Bing pack your application. They will use your resources more efficiently and things like that. You start getting more apps. Say you need to have application that will be providing some of the billing capabilities, and to expose this to outside world, you also need to have external IP address, so you need to also provide load balancer. And if you go into another service, this service also needs to have external address. So this creates some of the problems, because each service will have its own external IP address. In some of the cloud providers, this can be a limitation, because you might exceed, depends on the number of services you're running, you might exceed the pool of available external IP addresses. So smart people in Kubernetes world, they come up with this idea. Okay, so instead of having the multiple services will be exposed through its own load balancer, how about we will have something in between that will be responsible for routing things? So this is how they come up with this idea of Ingress. So Ingress, it's another Kubernetes object that will be sitting there. It also will allocate external IP address, but it will have a little bit more knowledge about how to route requests. Say, if you want to go to your billing service, it will have a route/billing, but or you can also route based on host name or whatnot. So we're going to be focusing on Ingress and how it works and why it is important. So first of all, it gives a very nice, clear entrance over how the traffic will go inside your Kubernetes cluster, so you can do some other interesting things on top of it. So Kubernetes Ingress, it is a vendor-neutral, again, vendor-neutral specification that runs inside Kubernetes cluster, and it really depends on one particular thing. It's what we called a Ingress class. Ingress class name. This is something that will distinguish this Ingress from others. If you're running Kubernetes, you're using stock Kubernetes, you're probably running something called Nginx in Ingress controller. That is considered as a default thing, but it's not necessarily needs to be default. More like maybe three and a half years ago, we were inspired. We at Kong were inspired by the work of community in Nginx Ingress controller. So we started building Kong Ingress controller on top of some of the ideas that were there in order to put the Kong gateway as a Kubernetes native Ingress implementation. So what is Ingress? It has multiple interesting things. So first of all, it has different paths that you can configure. So in this case, one of the paths that I want to expose that will be routed by by host name. So every time when I hit this ingress with a host header, I want to be routed to my back to future quote service. How does it work? Let's take a look. And you already seen that I do have some external IP address available, but also before that I provisioned my ingress. And if I go to the service, my gateway service already allocated this external IP address, and I also did some of the preparation where because I don't want to type the IP address all the time, I just created DNS record. conc.proxy.me. Oop. So that's the if I will hit this endpoint, so say I will just do HTTP conc.proxy me, I will get 404. I'll get the 404 because the way how the HTTP calls will work, every time when I will be hitting this using DNS name, it will transform this request into the part where it will get IP address of the service and also attach host header. Since my gateway doesn't know anything about this conc.proxy me header, we cannot do anything with this. But if I will go, say, to the same system, I will include. Actually, let me do this one. So if I will just do host back to future conc proxy me, and I get the response from this back to future service. And also for the sake of demonstration, I also included some of the additional information so you would know where this traffic coming from. So in this particular case, it's a particular pod that will be serving this traffic that's actually responding with this request. If I'll hit this a few times, you clearly see that some quotes actually coming from back to future quote service. So what you just see, this is particular case of routing by header. So every time, like when you go in your browser, you put this in your browser, and your DNS will resolve this IP address, and you will get, so basically to show how it works, I can even simplify this. I will just do this one. And I also get access to my back to future service. And if I will just do, let's do back to future, it's same IP address. So I'm allocating one IP address, and I already do multiple things. So I have one service that is available through conc.proxy.me, another service available through back to future, and just to do like a spoiler, that is there's another service that is also attached to same IP address from the different host. And if I will hit this, I will get access to the different service. So gateway in this particular case, or ingress, is responsible for routing based on certain rules. Those rules can be related based on, I'm showing examples to do route based on headers, but also it supports routing by path. So things that I showed you here with this picture, routing also can happen based on the path, which is also normal and very common. All right, so let's go deeper and see what is going on and what we actually can do with this. The way how it works, we take this specification that we defined our ingress, we defined our ingress class, and after that we submit this to Kubernetes API server. Kubernetes API server will translate this into some objects, and some of these what we call controllers that will be listening events that will be happening with these ingresses will be responsible for taking care of this configuration. I take this ingress, and it will convert this into Nginx configuration, it will convert the conc configuration, it will convert it into traffic configuration, whatever ingress controller you have. Really, every vendor that has some sort of like things to deal with APIs or L7 traffic management, they will have some similar capabilities. So since we're putting here not only just a simple web server, but we're putting actual API gateway, we actually can do many interesting things with the traffic. So say I want to do something with my APIs, and I want to provide tiering for my APIs. I want to have ability that some of the users of my API will have a different user experience. Say based on particular key, they might have a different SLA. So let me show you how this can be done with Ingress. So I like to joke about how other systems or other developers like to bash on Java, but everyone is actually taking a lot of inspiration from the Java things. And look at this. We have annotations here, annotations inside the YAMLs, and we have the annotations in Java, and everyone is taking annotation from Java. So this is the way how you can extend functionality of this vendor-specific specification and put some additional things. In this particular case, what I do, I actually have integration with few interesting things. One of the things that, in order for me to configure my DNS, I use this project called external DNS that will, based on this ingress, will read this information about the host name, and it will talk to my DNS provider and create this a record between my host name and my IP address that would provide it to Ingress. So this is kind of what I was saying, a little bit of magic and the luck, because DNS is always a tricky thing, especially when you do live demo. At the Kong Ingress controller, we also rely on this. In this case, we can enable some of the plugins. So if I'll go and hit my back to future and say, let's hit this on interval, let's hit this every second. And again, HTTPS, maybe the certificate is not provisioned. So let's do this repeat on interval every second. And let's see if we will have some interesting cool demo. Yeah, so after a few requests, we immediately get this error that too many requests that happened. And the way how it works, that I have the Kubernetes object called Kong plugin was created inside my Kubernetes. So if I'll go into my in my plugins, and I'll show you free tier. This is how this plugin looks like. Again, YAML, very Kubernetes, very Kubernetes style of configuring things. And what this plugin says, for a minute, on the free tier, users of my API, they will able to do only 5 requests. So this easy way to restrict access, very easy thing. So let's go and explore this a little bit further. So I want to have like a very cool API about Chuck Norris facts, and this API will be, where's my Chuck Norris? So for this, I would like to have a combination of the plugins. So I want different users will have a different experience here. Say, if some user will come with one particular key, they have one level of SLA. If users will come with different type of key, they will have a different layer, different level of service. So in this case, I do have a paid tier that allows me to give people 10 requests per minute. And in this case, I'll have a platinum tier. In the platinum tier, I have 100 requests per minute. And the way how I distinguish them is by the thing that we call consumer. That's the thing that will hold the state and will help to distinguish who is calling the service. In our particular case, we're going to be using API key, but JOT token or OIDC providers, all these things are supported as well. For simplicity, we're going to do this like this. And since I updated my and I go with my folder where I have my Kubernetes, go to Chuck, and I'll just do updated ingress. If it's still here, yep, I just do 03 ingress. So what will happen, ingress will be configured, and when I will hit my Chuck Norris service now, let me show you, there's one header that I will disable. When I send this, I get unauthorized because now Chuck Norris will be available only through the authorization. So if I will put this API key It's called please with the emoji. In this case, I will get response from Chuck Norris. As you can see, Chuck Norris can compile syntax errors. And let's see what else he can do. Chuck Norris doesn't need a debugger. He just started down the bug until, stares down at the bug until the code confesses. That's very funny. And as you can see here, as a response of this request, we'll have some additional information from the rate limiting plugin that says, okay, so you allowed to do 10 requests per minute, and you already used 8. Then we're doing next, and after that, we're gonna do one more thing to do. No, it's fine. I'm running Mac, and in this case, it should be enough for another 30 minutes or whatnot. Thank you so much. So now, if I want to change the way, say, go in the platinum tier, and I have a very cool sign of platinum users, they will use roundhouse kick to get access. And with the roundhouse kick API key, they will be able to do things with this hundreds requests. Okay? All right, so now there's a bunch of things available. Conk, like I said, is open source tool. Conk Ingress controller is open source tools. We at Conk we also build commercial offering, but everything what I'm showing to you is possible to do with the open source tool. So there's no tricks and sleeves. Now, you've seen some code. I do have an extended version of this presentation on my YouTube channel. There would be a link at the end, obviously, because everyone should have a YouTube channel these days. And I really want to spend a little bit of time to talking about future of this gateway API. So some of the things that I also like to show is non-HTTP type of workloads. I get examples with the gRPC. I get examples with TCP, UDP, because people running those type of workloads on Kubernetes. Every time you run a database and you want to expose this, you need to expose it through TCP Ingress. Conk Ingress controller can do that. Some of the Ingress controllers can do, some of them cannot. This is already kind of like a world of vendor specific, and this is kind of like a world where people in the community start thinking, okay, so Ingress is only designed to be L7 HTTP, and with the number of annotations, we can go very deep into this kind of like annotation hell. Again, people inspired by Java world, where we also have annotation hell, and they realize that there needs to be something else. There needs to be happening something new. And around maybe like 2.5 years, the group of people during the KubeCon, they come together, start thinking about how they can improve this Ingress API. So enter the gateway API. Naming is terrible. Naming is hard because now you can, what's the difference between API gateway and gateway API, right? But it was worse because the gateway API, before it was gateway API, it was called services API. It's even worse because the services, it's the super overloaded term. But essentially, what they did, they actually introduced a few more entities in the specification, few more entities in API that allows to have more clear separation between who is responsible for what. So key component here now is a gateway object. So gateway object essentially the thing that will be getting external IP address, external port, and this is the thing that will be routing your traffic. Gateway class, this is the way how the gateway operators or infrastructure provider will provide you with the choices what you want to deploy. Say you go into Google Cloud and you don't have anything to choose from because Google Cloud provides you with one GKE-based gateway class. And you create this gateway, you start pumping your traffic into your application, it's good to go. Now, if you deploy some of the vendor-specific installation of Kubernetes, you will get things like maybe some built-in ingress controller, maybe it would be traffic, maybe it would be Conk, maybe it would be something else. But you, as a developer, you really don't care. What you care about is routes, how you expose your applications through particular routes. So we have a gateways, we have a gateway class, now we have a different type of specifically designed API for specific type of workloads because HTTP routes can be different from gRPC routes. Also TCP and UDP routes, semantically they will be different. And after that, you connect those routes to your services. There's a more complex example that's kind of like it breaks down the things how developers can use it. Now, developers will have a full control over what they want to do and how they can expose their application. Don't worry about actual implementation of the gateway. They only say, hey, there's going to be like HTTP route / customers. And the cool thing is that, let's talk about this for a second. Gateway implementation, by default, will give you ability to route by header, by path, or by path and header. But people also want to have ability to route by weight. So say implement very simple or very rudimentary kind of like a blue-green deployment type of strategy where you can say that 90% of traffic needs to go to the service 1 and 10% of traffic go to version 2. So this is now part of specification. That's the standard thing, and now you can use this in your application. So the key component here that is happening over here is here. So those key components can be human operators, so there would be a specially trained person that will deploy this deploy this gateway, or that can be an automating operator that will be deploying those gateways. So, and we will, last week I was at the KubeCon, and now it is specification is a 1.0 standard, so we'll see multiple implementation from the different vendors very soon. Now, like I said, YouTube channel, please. Please subscribe to my YouTube channel. New videos every week. I'll talk about all things Kubernetes, cloud native apps, API management, service meshes, all this type of jazz. QR code for your convenience, and the screenshot so you know that you're on the right place. I didn't show it, so I'm not going to talk about this. So my name is Viktor Gamov, and as always, have a nice day. And I will be available for enhanced interrogation after this talk for whatever questions you have. I think we might have 1 minute for one question from the audience. So every time when there's a silence in the room, it looks like everything is clear or nothing is clear. And when there's a silence, it's very difficult to say which one is which. Please.
Yes, great talk, by the way.
Thank you.
How do you compare, especially with other ingress controllers out there, particularly ones integrated to the CNI like Cilium, on the features, and especially when it comes to multi-cluster? How does Kong allow maybe applications to be able to span across multiple clusters using this approach, and potentially even API gateway as well? If you can talk a little bit about that.
Yeah, so question was about multi-cluster application deployments and how this particular implementation of ingress control can help this. This is a very good question, and unfortunately I cannot answer this question in a very simple form because it requires a little bit background. Sometimes people saying that, oh, your Kong thing is running on Nginx, and Nginx is very old technology. Everyone is running Envoy right now. And Envoy is the future and things like that, and some of the implementations I just mentioned, they either use Envoy or they use something else, I really hate to do comparison about feature by feature. However, you brought very good use case, a multi-cloud. Multi-cloud application deployment is more on the side of how infrastructure will support application deployment. And I do have like I said, I have a talk where I'm talking about service mesh and how you can deploy your applications across multiple Kubernetes clusters using service mesh. And since I brought Envoy, the service mesh that we're working at Kong called Kuma has gateway implementation, same thing as I was talking about from perspective of gateway, but this gateway implementation uses Envoy. So technically at the Kong we have two implementation of gateways. One is Nginx based and one is Envoy based. So I would suggest you take a look at the service mesh, how it simplifies like a multi-cluster deployment. I have a demo on my YouTube channel about this, where I have a Google Cloud, Amazon, and I'm shutting down the traffic. There's a location-based gateway that would move application traffic to particular that will be close to you. So all these things are supported. So like I said, it's not a simple question to answer without giving a little bit more background. Cool. All right. So I will wait someone at the integration table. What?
Table 3.
Table 3.